A bromide is a chemical compound containing a bromide ion or ligand. This is a bromine atom with an ionic charge of -1. For example, in caesium bromide, caesium cations are electrically attracted to bromide anions to form the electrically neutral ionic compound CsBr. The term bromide can also refer to a bromine atom with an oxidation number of -1 in covalent compounds such as sulfur dibromide. Natural occurrence. Bromide is present in typical seawater with a concentration of around 65 mg/L, which is around 0.2% of all dissolved salts. Seafoods and deep-sea plants generally have high levels of bromide, while foods derived from land have variable amounts. Chemistry. One can test for a bromide ion by adding excess dilute HNO3 followed by dilute aqueous AgNO3 solution. The formation of creamy silver bromide precipitate confirms the existence of bromides. Medical uses. Bromide compounds, especially potassium bromide, were frequently used as sedatives in the 19th and early 20th century. Their use in over-the-counter sedatives and headache remedies in the United States extended to 1975, when bromides were withdrawn as ingredients due to chronic toxicity. This use gave the word bromide its colloquial connotation of a boring cliché, a bit of conventional wisdom overused as a calming phrase, or verbal sedative. The bromide ion is anti-epileptic, and bromide salts are still used as such, particularly in veterinary medicine. Bromide ion is excreted by the kidneys. The half-life of bromide in the human body is long compared with many pharmaceuticals, making dosing difficult to adjust. Bromide ion concentrations in the cerebrospinal fluid are about 30% of those in blood, and are strongly influenced by the body's chloride intake and metabolism. Since bromide is still used in veterinary medicine in the United States, veterinary diagnostic labs can routinely measure blood bromide levels. However, this is not a conventional test in human medicine in the U.S., since there are no FDA-approved uses for bromide, and it is no longer available in over-the-counter sedatives. Therapeutic bromide levels are measured in European countries like Germany, where bromide is still used therapeutically in human epilepsy. Chronic toxicity from bromide can result in bromism, a syndrome with multiple neurological symptoms. Bromide toxicity can also cause a type of skin eruption. See potassium bromide. Lithium bromide was used as a sedative beginning in the early 1900s, but it fell into disfavor in the 1940s, possibly due to the rising popularity of safer and more efficient sedatives and when some heart patients died after using a salt substitute. Like lithium carbonate and lithium chloride, it was used as treatment for bipolar disorder. It has been said that during World War I, British soldiers were given bromide to curb their sexual urges. Although this is not well supported by documentation, and has been disputed as an urban myth, as the sedative effects of bromide would have hampered military performance. Lord Dunsany mentions a soldier being given bromide as a sedative for nervous exhaustion and overwork in his play, Fame and the Poet. In biology, recently, bromine was shown to be an essential cofactor for the peroxidase and catalyzed formation of sulfilamine cross-links in collagen IV. Since this is a post-translational modification that occurs in all animals, bromine is therefore an essential trace element for humans. Bromide is needed by eosinophils, which use it to generate antiparasitic brominating compounds such as hypobromite. By the action of eosinophil peroxidase, a haloperoxidase enzyme which is able to use chloride, but preferentially uses bromide when available. Other than its role in collagen IV production and its facultative use in eosinophils by the body, bromide is not known in other cases necessary for animal life, as its functions may generally be replaced by chloride. Land plants do not use bromide. Bromide salts are also sometimes used in hot tubs and spas as mild germicidal agents. using the action of an added oxidizing agent to generate in situ hypobromite, in a similar fashion to the peroxidase in eosinophiles. Bromide is perhaps a minor necessary nutrient for collagen IV-producing animals in the sea. However, a few sea animals, such as murex snails, use bromide to make organic compounds. Bromide ion is also heavily concentrated by some species of ocean algae, which construct methyl bromide and a great number of organic compounds with it, using the unusual enzymes called vanadium bromoperoxidases to do these reactions. The average concentration of bromide in human blood in Queensland, Australia is 5.3 plus or minus 1.4 mg/L and varies with age and gender. Much higher levels may indicate exposure to brominated chemicals. However, since bromide occurs in relatively high concentration in seawater and many types of seafood, bromide concentrations in the blood are heavily influenced by seafood contributions to the diet.